Okay, today is very important. I'm trying to formulate this problem very well, but I'm gonna watch a video. People will see my face. I'm gonna work on this paper, but I'm gonna see what I can do it properly. So, what I'm trying to formalize? The problem is basically in three parts, but let's get to the problem statement for the video. So the problem statement states as follows. I'm trying to have two implementations of a system. I'm trying to have a and quantum system and quantum system and a quantum system for energy and power, energy and power, relation between energy and power as seismic activity. So energy and power formula. So you get and this is wireless. So you get the reduction of system of power, electrical power. So the power is measured in watts. So you get the measurement of power to watts. But I'm trying to finalize two. I got two sheets of paper here. I don't think it's enough, but let's see how this goes. Yes, I'm going to put it here. So you get information of power to watts. So first thing I'm supposed to do is formalize a system for power in relation to energy. Because we have two types of energy. You got potential energy, which is via work done in the system, efficiency. So you get three formulas now. So I'm just you see my face. You can see me trying to work it out. So I don't share papers here, but I'm trying to work it out myself. So I'm gonna take a sheet of paper out and start showing you guys how I do it. You guys gonna see my handwriting and everything. I'm gonna finish your paper. So I'm gonna take a one because the way from there. So let me issue one. You can see it here. So you see my laptop here. I'm gonna put it here. Oh, it's usually better here than access, Yeah. So you get it here. So I'm going to go like this. So I'm gonna be here doing this. You get electric current. So I'm on maths.fun for.com for physics for such electric power. Electric formula for power is power equals current times voltage, which is difference in current. So power is measured in watts. Power is watts. Current is amperes, and V is for voltage. But I'm reading this article myself, so I'm gonna go to read mode and try and formalize it. But the problem I'm supposed to solve, right? So the problem is a distillation of formalization that for power distillation, and basically power distillation via mathematical verifiable work done in a system so you get in an open closed system or closed system formation of power decision given 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 work given work work equals displacement times force, given power equals current times voltage, because work equals efficiency. given power, because we get the last one, and given energy equals mass times mc squared, mass times c squared, energy formula. So you get energy formula, energy, so you get energy formula. So I'm now switching to seismic waves. So I'm going to watch a video on seismic waves, but this is the first problem. So the first problem is basically to solve this problem. But I'm going to run three problems down, trying to solve it. So energy is stored in a system. The equation we use to quantify how much is stored. Energy is conserved. It is no critical chemical energy between states stores. Or energy between stores. So energy is stored found. It's not critical. So energy in gravity potential. So you get to gravity energy equals mass times. Okay, okay. So you have potential energy. Energy P equals m times g gravity times h times height. Where c is constant, so you get energy equals mc self, where c is constant. You get that's potential energy. Energy sub p. You have kinetic energy. Energy system E sub k. E sub k is defined as half so half times mass, half times mass times v squared. Velocity velocity squared. So, and the second one of quantifies is the size. Let's start with the other second thing. So, four letters. So we got my writing here. Come see my writing. Okay, can you see my writing, guys? No, you don't need to, guys. So you get this TV here saying a lot of stuff, but uh, so um, to formalize a power dissipation via verifiable work done in a system, open and closed, given work equals displacement times force, power equals constant voltage, and energy equals mass, position energy equals mass times gravity times height, where gravity is a constant, and E sub k half times mass times velocity squared, which is the half speed is going. So anything that's a vector has a movement, magnitude, and this is a vector is called velocity. And no, the second part of the proof is seismic Fourier series. So Fourier series to Leptonian. So I have this thing here. This is one, two. So the Leptonian of the system is here. So you got the Leptonian here. Yeah, so a following the first is a special. Okay, so read aloud. No, so this is square wave. So I'm gonna hear the sound bit. How does it sound like? Sound bit, a photograph of me. So I'm gonna leave this one, yeah, but square wave is I'm gonna duplicate this time. So basically, you go three parts. You get the Fourier series. So Fourier series is just a magic unit of signals. They're signals, but those signals are synergy waves. So Fourier graphs, Fourier series and sequences are ratios of waveforms. For example, you have the square wave. Square wave is defined as, let me go out here, read mode, out of read mode. Can we use sine waves to make it square wave? Yes. So yes, I'll talk you through this code. So you have sine plus cosine wave to make it square waves because you know a square wave. So we have two waves, sine and cosine. So let me just read that. So I'm gonna start this one with read aloud mode. So we're gonna start. Okay, stop. So we get we get the height thing. So you get, can we use sine waves to what to describe? So you get a sine, start with sine x, start with sine x, then take three x over sine three x or three x over three, and you get inverted. So you get start with sine x. Sine x will basically do something with three x over three will be three units x over three. 3 to 5. 2 to minus 4 h 1. Get, I'll add up. I'll take, so I'm looking at the way to do it. So you start a sine wave, a sine x, and you then take sine 3x over 3. So sine x is basically, okay, so you having a wave propagate on the x-axis. Basically, the wave is basically you're gonna sine x. You have to have this is basically works on y-axis. This is basically y over x you're doing. But this is sine. This is the opposite of hypotenuse. But the y is represented as the x is the dimension of the y. So the x has it's basically operating up and down, but it's taking a curve up and down. So it goes down and then it goes up. So this is y over x. But y is basically the axis of, it has to go up at some point. It has to peak. You know, and you get sine 3x over 3. 3x is basically 3 times x. So yeah, it goes from it scales, so basically it becomes more frequent, 3x divided by 3. And that's what I'm saying. So you get 3x divided by 3, you get three frequencies, the wave smaller, the wave smaller, but propagate three times as much. So you give me three times of x, three times x. So we're going to be more frequent. So it goes from minus pi to the zero, but there's two, three, one, two, three waves that propagate there, and then you have 12 minutes time. Then you have three. So you get a formula here. So this I've been doing now. So you get this work here. So you get this here. So it's my work so far. So distillation of formalization of the system, and you get two Fourier series. You get Fourier graph. So you get 3x over 3. This repeats 3 times in the space of minus pi or negative pi to 0 to pi. And this repeats 1, 2, 3. But this is a function of 3 in 1 unit, but that is span the height of the dimension of y of x. So it will be in a quadrant, it will be between the base and height of x. So it will be minus pi to 0. It will be half of pi. So you get from so you get, then you add sine 3x over 3x, you get 3, sine x. So we can say sine x equals 3x, but if it's to sum, so sine x equals sine over 3x over 3 or plus psi over infinite. This is a Fourier series. These are the idea of Fourier series. So this is an infinite series, because series is basically can be infinite, but it doesn't have to be infinite. It's by the infinity signs and cosine, you can take a sequence. The sequence is not a series, so mathematically speaking. But I'm talking about series as in double space half time computation. But same thing you have in mathematics series, something about mathematics series. The photographer. So also you have a spiral artist. You have some how sequence makes up waves. Finding the coefficient. So where fx is the function we want, such as the square, L is the half period of A, fx equals AO theta equals cosine n over L. What is the half of the period? So L is half of the period. Yeah. So okay. So yes. A0 equal to L. What is integral L of this? This is an integral, but it means you have to find an area. So the net area is f of x sine nsl by L, which is minus ln integral rules. Okay, so it's basically I'm trying to find the integral, but I'll come on model here. So the second one is a single waveform. So you get sin sine ojo, and you get cosine you do, but you get ojo waveform. So you get sine, you get cosine you do, you get cosine, you get tangent you do, you get secant, you get cosecant, and you have inverse tan, which takes the degrees and gives you the rate angle. So I want inverse tan. So you get the inverse of, so you get 1 over sine, 1 over the inverse sine, 1 over cosecant, and 1 over sine, cosecant, 1 over cosine, 1 over cosecant. These are all mathematical objects, but they have half a period. So my last problem is have a proof system for this kind of system via the symbol of L, which I mean half period. So where's my work on half period? So I find a coefficient f of x equals a So you can have from 2 is related to 3, but 2 and 3 are related problems, but they're different problems to solve differently. So problem 2 is to have a Fourier graph to solve the sine cosine function. The sine to have a kind of a waveform function. So you have a square wave, clearly defined as Fourier series. You have a triangle wave, you have a sine wave, a sine wave, a triangle wave, you get a sawtooth, you get a sawtooth wave. You get a sawtooth wave. So the sawtooth are waves ahead like this. So, sawtooth, triangular, get square. So this is what I know so far. But the series can be different series. So this series can be infinitely, that's what I mean. So as you can see here, this is sawtooth wave at the bottom. So the sawtooth wave is the first series that has that basically detects the kind of energy in the seismic activity. So it's basically to say that you get a seismic activity such as an earthquake, and you can enhance take energy from that system of the earthquake. But sustainable energy has to come out of the system, so energy has to come out naturally, and you get a standard one of force of newtons and force. So you get some kind of formula I had before, biological. So you get formulas like 32 Fahrenheit equals 0 newtons. So, this is a process. Okay, you don't have some correct energy, but I just know that one. That's why I made it up. But the two Fahrenheit. So that's not really down. So you get that. But the sawtooth is basically, see, it goes up and down, up, down, up, down, up, down, up, left, right, down. This is a sawtooth. Typically, it's like someone sawing through some kind of wood. But it's basically a sawtooth. But it's basically tooth from saw. But, it goes up and down because it's energy. It's energy. It's a signal of energy. So you get no noise, no signal, noise, and no signal. So you get no noise. You get no noise means you have no error in the system, no energy. So no energy. But this is the sequence state. So this is sequence state. So no noise again, no noise every day, no entropy, no disturbance. And you get noise. And the noise means like the system is noise. You get energy, and you get danger. And you get danger, you get no signal. That means you then have no connection to the system. So you get this kind of thread to get altogether signal, which is a connection to energy, so or power. So you now get power attributed to you because you need to work mathematically. So this first is going to be for 5 minutes, it's getting kind of long. And I've not done the third one, so I'm going to try to do the third one and then give you the formulation of it. But the first is just quickly the last one I'm going to try to do. So you get the first problem, which is the last problem to do this. So I have here an Newtonian model for energy measurement. So you want to system to give you energy. You don't want something to you don't want to take energy because energy is already there. So you don't want to take energy. You want to just give you this. In an open system, energy is allowed to go in a closed system, nothing is allowed to give it to be take inclusive, not inclusive. So when you're thinking about closed systems now, nothing is only allowed to give you anything allowed to take away energy. This is mutation in form, energy in the form of energy. So I'm saying, so you have a half a period. This is L, half a period. Half a period. L half. We have half of one. Half L sub half or L sub half. L half, which is default half. So you get L, which is L half. You get L. So you get L, which is equal to L half. Which is like half the period. Half the period of the system. For example, you will get for the first second column, 180 degrees is half a period. 180 degrees is half a period. Then 180 degrees is half a period, and then you get half a half. You get 90. So you get a quadrant, which is 90 degrees. 90 degrees. So you go. This is not really goal here. So yes, this is goal. So you have 4 quadrants. One, one, two, three, four. So 1, 2, 3, 4. So and you get 4 quadrants. One, two, three, four. And these quadrants are determining the kind of period measurement we take of periods. The periods are just what determines minus pi to pi over oscillation frequency. Because you get minus pi, that's what you get minus pi, which is basically the oscillation of an axis. So you have a lesson. So I'm just take the quantum measurement of electron using this framework of oscillation. Because if I can generate an energy, that means it's friction. So for example, if it's friction in the system, that means the energy already. So for example, friction is defined formally as Newton's cradle. Newton's cradle. So you have you have energy. One cradle, one bead hits one, two, three, four. Two, three, four. Hit one bead and the energy propagates in the system. That system is friction. So the friction, the energy goes from this bead on the far left and goes to the right, and the energy starts to dissipate. So, if we can harness the friction, as energy, if we can measure friction as force, if force equals mass acceleration, the friction is the friction. There's a slow of the force minus F. So minus F equals that system, so slowing that system down, and that's the energy. So the force slowing the system down that keeps it is efficient, and that's what the energy is dissipating. It's not dissipating, that's the energy. So what's the hard on the show? The same amount, so you get 5 beats on the Newton's cradle. But if you swing one bead 90 degrees, you can take a Fourier series of a system. A Fourier series, no. If you move one bead minus 45 degrees from the resting place, minus 45, minus 65 degrees from the resting place. That energy will from force rest, which is like a net force equals 0 to minus 45 degrees. Then the force will be mathematically verifiable to the system of Fourier series. But I'm not doing I'm just you go to have take a measurement of a quantum system via the framework of organization system. For example, you have the sawtooth. So I'm trying to generate the sawtooth. I'm trying to generate energy. I'm trying to get energy not just from the system that's gonna give it to me. Because if I measure, if I have a quantum system, if I have to draw, so I have to draw in here. I'm trying to complete it now. I have an electron in the center X. So this lepton is basically an electron. I'm trying to excite an electron to a state of positron, and that will be the energy. So I'm trying to have a sequence of measurement I can take, to excite an electron. That's the third one. To using the fact via the bead one to have friction. So the electron is basically so I want to turn an electron into a positron, and that positron will be so I have to go to so the third one. So I have the third one. I have a lepton denoted at this kind of circle in the center, that's being measured. You get a lepton or electron, E, big E, this electron, and this isolation, I just have to face minus 45 degrees. So I can take a measure at any angle, any period. I can take a measure from minus 45, minus 45. So this minus 5 will be a half, or a quarter will be one dimension. So that one dimension will have an apple, and that apple will basically be do I so have I described have I ever described the concept? So that will be have I got a soul, a triangle, triangle waveform or a sign, what have I got? If I've got the right thing, I can now continue to have take a second measurement. So you get a half plus a half, I get a quarter. But if I have a half and a half, I get an eight, and I have no energy. So I have a half, a quarter, plus a quarter, 1 divided by 4. I get 1 divided by 2. And that's basically half energy. But that half energy is basically half not energy. I can get, when I take the final measurement, I will get half energy or half nothing. So this will be half the energy that's in the system, if there's a system. But it's basically like, zapping protons, zapping electrons from every angle to make it a proton. And that would be positive charge. So you can rotate the axis twice, because, you can have 2 electrons to 1 proton, because these leptons electrons have no mass, so they won't have a mass. But when you when you say they are neutrino electrons, so your electrons can be as waves as electrons. Or you have neutrino electrons, which have neutrons in the system of mass. You have mass. You can see some. I'm talking about a neutron electron, which we can actually measure mass. But the mass has to not be fused to something else. So we go to have something that's cohesive enough. See this joint here. So in this joint we have electron in the center of the system, and this electron represents the E. You get e to the power negative one. So you also make it charged or positive, and that positive will be in a system of like something that's cold, because it's basically a cold system, superconducting system. Um, you know, you get a conductor of electricity, you get a superconductor of power. So I don't know about superconductors, but I just know about electricity conductors. Because, if you get water in the system, you get tomographic conductor for the electrician, based on the measure, principle, but it's a harder proof to do, because the electrons have angles of minus 45, minus 90, minus 80. When taking the measurement, it's very important to take it. And if you don't take the right measurement, you can get your energy disappear entirely on you. So you get the square wave and sine wave and sine wave, but these are all mathematical waves. And you get one more, so you get this kind of model here, and you get here. So now the problem again, problem equals current times voltage. What equals amperage and voltage? A form for polarization. Fourier as leptons, Fourier as seismic wave activity. So the last video I'm gonna make is on seismic activity. So let me go make that video on seismic. So I'm gonna watch the video now, guys. Let me see what I can watch the video and see what I can talk about. It's I saw you guys. I'm saying so we got a focal point here, but hypo H Y for EP, P for Papa, O for Otto, EP. S Y P S Y P S S. Oh no! So so it's basically so the epicenter is basically the center, where the energy starts from opposite the lamp, which is basically the epicenter, which is the top surface. Where the first example you get the hypocenter, which is the center of the center where the energy started. You get the nearest neighbor, nearest you get a fault. Nearest is the nearest to this epicenter is like a crack. That's near the answer you get a fault, which is actually something that is cracked outside the system. lucky we're going for ditch. Okay. Thank you guys for watching. So that's the video down. Let's get this started with okay. Thank you guys for watching, guys. Like, share, subscribe. This is my work so far. This is going to picture. I don't really hate myself, but I don't hate myself. It's what can I do? It's by the sawtooth triangle wave and square wave. Power equals constant voltage, energy equals mass is squared position equals the energy. Get power. You get dimensions of it. So the measures of the beam of light, the beam of something, measures of the beam of something, the beam of sample. It has to measure. It's like you have intensity of it. So basically, you have to take a measurement by observing kind of mirror, which is the density of the system. So you get 1/1,000, 1/100, 1 divided by 100. 1/100th of a measurement, 1/100th of a measurement, which is the wavelength to take a measurement. You get 1 divided by 10 of a measurement, which is a electron. Then a muon, you get 1/1,000 of the measurement of 1,000, which is like a measurement of the system based on density. So if based on dimensions of process, if they are so if you want the tour is TEU is what's on the ground. So that's how the measurement works. For the so you have to use the quantum principles involved in dimension principles. So you get like an error. So if this is like this was here is like a 1/10. If you go travel 1/10, so I'm going to now travel 100. 1 divided by 100, for every one left, one more has to go 100. 1,000 has to be very deep in the crust to get the measurements you need to get the energy you want from the system. We get less than proof. Okay. Thank you guys for watching.